Hey everyone, today we're going to be going over Unit 1, Lesson 1. You'll always know if you have the correct packet in front of you by just looking in the top right-hand corner. U1 means Unit 1, and then Lesson 1, that number is always in the top as well. Okay, so also we need you to just make sure that you're writing your name at the top of each page to ensure that you can get full credit for all of the work that you're completing. All right, so as we look here, Lesson 1 is number properties and combining like terms. So the do now asks us to simplify each of the following expressions. So if you look at part A, if you can maybe remember from last year, anytime you see parentheses, this represents multiplication. So it's asking me what's 3 times 8. You could type that into a calculator and you would see that the answer is 24. Part B. What's 13 plus 6? Again, very straightforward. You would type it in and get 19. Part C is also multiplication because I see those parentheses. 7 times 3 is 21. Part D, 6 plus 13, type it in. You should be getting 19. And Part E, again, I'm seeing those parentheses, which represents multiplication. So 8 times 3 is 24. Okay, now if we jump down to number 1, it says describe the similarities between problems A and E. So that keyword similarities, it just means like what's the same. What am I seeing that's very similar between A and E? Well, I can see the answer to part A is 24, and the answer to part E is also 24. So we can say that they have the same answer, but a more common used word in Algebra 1, instead of saying the word answer, we like to use the word solution. And if we take the regions, that's something that you would see on the regions. It would say, what's the solution? And again, that means what's the answer? Underneath it says, why do you think these problems have the same solution? So why do you think they have the same answer? Well, if I look at A and E, they both use the numbers 3 and 8, right? 3 and 8. And they both use multiplication because I see those parentheses. So it doesn't matter. 3 times 8 is 24. Or if I switch it, 8 times 3 is 24. So again, why do you think these problems have the same solution, the same answer? Because both problems are using the same numbers, right? They both have 3 and 8, and they're also using the same operation. And what is that operation? It's going to be multiplication. All right. So now if we look underneath at number 2, it says describe the similarities between B and D. Well, if I look, B and D also have the same answer, or that better word, right, the same solution. So I'm going to write they have the same solution. And again, why do we think these problems have that same answer, that same solution? Well, if I look, I'm adding 13 and 6 in part B, and I'm adding 13 and 6 in part D. The numbers are just switched. That's okay. So I'm going to put a very similar answer. Both problems use the same numbers. They both have 13 and 6, and again, they're using the same operation. But for this example, that operation is addition. Okay, as we move underneath, this is super important in math. These are probably the 2 most common properties that we're going to be seeing, and we just actually saw them in the do now. So if we look, we're going to be working with the commutative property, and then we're also going to be working with the distributive property. The commutative property is a little bit easier to remember, I think, just because the commutative property, it moves things around. So you commute to school, usually every day. You get on the bus, you leave your house, and you come to school. So you're commuting, you're moving, you're going from one place to another. So if I look at the definition, it says if A and B are real numbers, then A plus B is going to equal, it'll be the same thing as B plus A. Same thing with multiplication. If A plus B are real numbers, then A times B should be the same thing as B times A. Now, I know just like you boys and girls, I do get the same way. I don't really, I feel like learn a lot from this. I need to see like a real example. So let's jump over here on the right. So I'm gonna let A be the number 5. And I'm gonna let B be the number 1. So it's telling me 5 plus 1 should be the same thing as 1 plus 5. I'm just replacing these letters, these variables, with numbers. And I know that's going to be true because 5 plus 1 is 6, and 1 plus 5 is 6. So this checks out, and it works very nicely. Same thing with multiplication. Okay, same thing underneath. Let's do 2 and 7. So I know that 2 times 7 should be the same thing as 7 times 2. And we can check it. Well, 2 times 7 is 14, and 7 times 2 is 14. So again, that worked out, and I know that it's true. And again, we're just commuting, we're just moving the order of the numbers. Now, if we look at distributive property means to multiply to each term. That's going to be inside parentheses here. So if we look at the definition, if A, B, and C are numbers, right, real numbers, then I know A times B plus C, everything that's inside, it's going to equal A times B plus A times C. Again, I need to see a real example. I don't know if this is super helpful, so let's jump over here to our examples. So I'm going to let A, maybe for this example, be the number 2. I'm going to let B be the number 3, and C be the number 1. So all it's telling me to do is I'm going to take this A value and I'm multiplying it to B. That's how we got AB. Then I'm going to take this A value and multiply it to C. That's how I'm getting this AC value. All right, and we were using addition, so it stays the same. So I'm going to do that here. So 2 times 3 is 6. And I know that 2 times a positive 1 is a positive 2. And that's how I would use the distributive property on a question like this. All right, moving on to the next page. All right. So if we look at the directions at the top here, they just want us to practice the properties that we just learned. So it says describe the property that's happening in each of these examples. Okay, so there's 2 properties that we just went over. There's the commutative property, commute, you're just moving around. And then there's the distributive property, which is changing the example, right? Because I'm multiplying those numbers together. So if we look at number 1, I'm just going to ask myself, are numbers just moving around, or are they changing completely? Did I multiply them together? So let me check. Number 1, am I just moving 3 and 11 around, right? It was originally 3 plus 11, and now it's 11 plus 3. Yeah, it looks like I just moved those numbers around. So I'm going to say that this is the commutative property that I'm looking at here. All right, let's do one more. If we look at number 2, same thing. I'm going to check. Am I just moving these numbers around to get from the left to the right? Or did I actually multiply? Are my numbers changing here? So I'm going to go ahead and look. Well, originally I had a 2 times 5 plus 1. And I'm not seeing anything that resembles 2 times 5 plus 1 on the other side. It looks like we multiplied. So I'm going to check. 2 is in front. So I'm going to distribute that number to everything inside. 2 times 5 is 10. 2 times a positive 1 is a positive 2. So yeah, it's safe to say that we use the distributive property on number 2. All right, I want you to take the next let's do maybe like a minute or two. And I want you to try numbers 3, 4, 5, and 6 on your own. And at this point, just pause the video and then check back for your answers in a minute. Okay, so if we look here at number 3, same thing, we use the distributive properties, so I know my numbers changed. I was actually multiplying here. Number 4, it looks like it would have been the distributive property because you see those parentheses, but it wasn't. We didn't actually multiply anything. We just commuted. We just moved things around. So instead of it being 4 times 3 plus 6, now it's 3 plus 6 times 4. All right, number 5, our numbers changed. We actually distributed, we multiplied out. So distributive property. And then number 6, we just moved these around. Instead of P plus 10, now it's 10 plus P. All right. Now if we look underneath at our next set of notes, we're going to check out what like terms are. This is going to be a lifesaver for most of the year. I'm going to just highlight this because that's how important it is. So as I'm looking for what like terms are, here's how I'll know if I'm looking at like terms. It says you have 2 terms. I'm going to highlight that. And those terms have to have the same variable, and they also have to have the same exponent. And then again, if that's true, we call these like terms. If we look underneath here at our example, it tells us that 6y and 3y are like terms. I'm just going to highlight that. And I know they're like terms because they both have the same variable, which is y. And it also tells me they both have the same exponent of 1. So let's check that. The same variable, okay, same variable would be y. They both have a y, they both have a y. Check. It also says they both have the same exponent of 1. Now, an exponent is that little number in the top right-hand corner, and I'm not necessarily seeing that here, but that's okay, because I know there's an imaginary 1, and I'm going to write that in. So it's really y to the first on 6y, and it's really y to the first on 3y. So they both have the same variable, same exponent. These are good to go. Underneath, these guys would not be like terms, all right? Even though they both have an x, I'm seeing an x on the left and an x on the right, their exponents are not the same. Again, this has an exponent of 2, it's clearly written, and this has an imaginary exponent of 1, right? He's invisible, we just can't see him, so we draw it in, no big deal. All right, those don't match, so they're not like terms. Now I want you to practice underneath identifying like terms on your own. I'm gonna do number 1, just to make sure we're all on the same page, and then you're gonna try number 2 by yourself. So if I look at my example here, my variable is x, and my exponent is 2. I need to look for all terms that have an x squared, or an x to the second power. Same variable, same exponent. I have an x, but this is really to the first power. This does not match. Next. Well, this doesn't have an x at all, it has a y, so right off the bat, not gonna work. This has an x, it has to the second power. These guys would definitely be like terms. Again, this has an x, but it's to the first power, doesn't match, they're not like terms. All right, so this is the pattern that you're gonna use to identify if you have like terms or not. This is x to the first, I need x to the second, not a match. X to the third, not x to the second, it's not a match. Not a match because it's x to the 6. Oh, x squared, matches. X squared, matches. X squared, and it matches. All right, so that's how you would do number 1. You just need the letter and the exponent, that is it. All right, so I want you to try number 2. At this point, again, just pause the video and try identifying those like terms. All right, so if we look at number 2, I can clearly see here that my variable was a, and my exponent was 4. So I'm looking for a to the 4th power. I have it here, 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 and here. All right, all those other examples don't match, so I should only have 5 answers for number 2. All right, moving on to the next page of notes. So as we look here, we're going to be combining like terms. Okay, so if I want to combine like terms, where am I here? It says when combining like terms in algebraic expressions, there's 2 steps. All right, the first step is you want to identify those like terms. So that's step number 1. And then step number 2, we want to add the coefficient. Coefficient is the number in front, and we don't want to change the variable and the exponent. All right, I just want to quickly identify all that important information. So the first step, identify like terms. After we've done that, second step, we have to add the coefficients, but we have to remember not to change the variable and the exponent. So if we look at our example here, step 1 is to identify the like terms. We just went over on the last page what like terms are. Like terms have the same variable and they have the same exponent. So if I look here, variable and exponent, x squared, variable exponent, x squared, they match. So now that I've identified my like terms, step 2 says that we have to add those coefficients, those numbers in front. So I'm going to add 3 plus 8 and get 11. Okay. And then again, we're going to keep the exponent the same. We're keeping the variable and the exponent the same. So now it's going to be 11x squared underneath. This didn't match, so he just comes down for the ride. All right, let's do one together. So if we look at the directions underneath, it says for each of the following, we want to combine like terms. Step number 1, we want to identify our like terms. If I look here, I have a to the 1st power. Now I'm going to check, does anything else match? Yeah, the second guy matches. He's also an a to the 1st power. So when you have your like terms, you want to circle those. So I'm going to circle 3a to the 1st, and then I'm going to circle a positive 2a to the 1st. You always want to include the operation if you can. And now I'm going to go ahead and start combining because he is not an a to the 1st, so it's not a like term, I just leave it alone. So now that I've identified, step 2 says I want to add those coefficients together. Okay, so 3 plus 2 is 5. So now I have a 5a to the 1st power. And then this 4a to the 3rd just drops down, he comes for the ride. And this would be my final answer for number 1. Let's try one more, and then I'm going to let you try the rest by yourself. So if we look at number 2, same thing. First, I want to identify my like terms. So the first guy has x to the 4th. No x to the 4th. Oh, x to the 4th. Again, I'm circling with that operation. And no x to the 4th. Okay. Now I'm going to go back. Well, this guy has an x squared. Oh, this one is also x squared. So these are also like terms. I'm using a different symbol. You could use a box. You could, make a triangle around them. I just use a little squiggle. I just think it looks nicer. Okay, now I'm going to go ahead and start combining those like terms. So if we look here, 5 plus 2 is 7. And now it's 7x to the 4th power. Okay, done. And then my last 2 like terms, I'm going to combine. This coefficient is a 3, right? That's the number in front. I don't know if I see one here, but that's okay because I know there's really an invisible 1 out front. All right, so 3 plus 1 is 4, and it's a positive 4, right? Positive 3, positive 1, positive 4. And then the x squared stays the same. It just drops down for the ride. All right. The most common mistake, boys and girls, is that we like to change those exponents up top, And the only reason you don't is because if I have 5x to the fourth in this hand, and I have 2x to the fourth in this hand, when I put them together, now I just have 7x to the fourth. Same thing with cookies. If I have 1 cookie in this hand and 1 cookie in this hand, now I have 2 cookies, not 2 cookies squared. All right? Please try numbers 3 and 4 on your own. At this point, pause the video and then check back for those answers. All right, so here we go, number 3 and number 4. I circled my like terms, or in number 4, I also underlined my like terms and combined them, and that should have been the answers you got. All right, at the bottom is your closure. So this is just a question that you should be answering on your own to make sure you understood what the goal of today's lesson was, to try those questions by yourself. All right, so again, try to just pause the video and then come back. All right, so if we look here, number 1 says, which real number property is shown below? And you have to explain your choice. That is probably the most important word here, is explain. A lot of us sometimes have trouble with that. Even me, it's sometimes hard to explain why an answer is, what it is. But you got to just do your best. You got to use all vocab anytime you're explaining. So what property was being used? The distributive property. I can see here that we must have multiplied 2 to b and 2 to -9. And that's how we're getting our answer on the right-hand side. Explain, I use the distributive property because each term was multiplied. Number 2, explain in your own words why these guys are not like terms. Well, like terms need to have the same variable, and they also need to have the same exponent, and this one doesn't. It has a different exponent. Here it's a 4, and here it's a 3. It should be matching. Okay, and then last but not least, the very last page is always homework. I would just highlight this quickly. Homework needs to be completed on your own, and you need to show all work. So don't just write an answer, make sure you're showing the work as to how you got that answer if you want to receive full credit. All right, again, make sure you're writing your name at the top of each page to make sure you get that full credit. And if you have any questions, feel free to send an email. Okay, awesome, we got through lesson 1.